Welcome to this eLearn Security video lesson on Wireshark. Wireshark is a network sniffer and protocol analyzer that you can download for free from wireshark.org and that you can find installed on Kali Linux by default. In this video, we will see how to use Wireshark to capture and inspect network traffic. Moreover, we will see how to set, display, and capture filters, and how to save your captures to a file. Let's start by running Wireshark from the application menu. Kali Linux, Top 10 Security Tools, Wireshark. If you are running Wireshark in a trusted environment like Lab or any other trusted network, you can ignore the warnings and run Wireshark as root, the default Kali user. But if you plan to run Wireshark on an unknown network, we strongly recommend that you run Wireshark as an unprivileged user. You can find information on unprivileged traffic capture in Wireshark's manual. To capture some traffic, we need to choose what interface to use. We can do that by clicking on the Interface List button on the welcome screen. As you can see, the Capture Interfaces window displays the very same information you can find in the Interface List tile of the welcome screen. To set our capture options, we can open the Capture Options window by clicking on the Options button in the current window, or we can open it from the welcome screen. Let's close this window and open the Capture Options window. This window lets you choose the interface to use during your traffic capture, your display and name resolution options, and your capture filters. To filter a capture, you can click on the Capture Filter button. Capture filters are a great way to select the traffic you want to sniff. As you can see, there are some default common filters, but you can create as many filters as you want by using this window. We want to capture all the traffic during this first session, so we can close the current window, choose the sniffing interface, and then click the Start button. There are some different ways to configure and start your sniffing session. It is up to you to choose the right one for every capture. As usual, experimenting is the key to master every tool and technique you learn during our courses. Wireshark is now sniffing. Let's generate some network traffic and see what happens. To do that, we can open the terminal and run some command line networking utilities. The traffic will be recorded and the packets displayed in the capture window. During this session, we will run some tests on two hosts, admin.site and other.site. Please keep in mind that these are some example hosts created for this video in eLearn Security's labs. These are not real hosts on the internet. The first command we run is the ping utility on admin.site. We type the ping command followed by the name of the target host and hit enter. As soon as the ping utility starts to send and receive packets, Wireshark's capture window populates itself. Let us now hit Ctrl+C on the keyboard to stop ping. To generate some DNS traffic, we can run nslookup, admin.site, and then nslookup, other.site. To generate some HTTP traffic, we open admin.site with the browser. Please notice how Wireshark captured much more packets compared to the traffic generated by the ping and nslookup utilities. Finally, we log into admin.site by entering the username and password. Wireshark also captures this traffic. We can now minimize the browser window and stop the capture. Wireshark lets you save your capture in a file. To do that, you have to click on the File menu and then click on Save As. We change to the root's home directory. Name the file Capture PTS and click the Save button. Saving a capture lets you perform your analysis offline as you will see in the full stack analysis with Wireshark video. This video focuses on the user interface and the configuration options. Wireshark displays the captured packets in this upper pane. The upper pane, by default, contains 7 columns. Every row in this panel represents a packet. The first column contains the sequential number of the packet. This is the order in which the packets arrived to the network card. The time column displays the time of arrival. This time is relative to the start of the capture. For example, the first packet has a time value of 0, and one of the latest packets in the capture has 71 seconds as the time value. This is because our sniffing session took a little more than a minute. The third and fourth columns contain the source and destination address of a packet. These addresses are protocol dependent. For example, the first 2 packets contain MAC addresses, while the third and fourth contain IP addresses. These first 2 packets are displayed with human-readable MAC addresses, both for the network card's addresses and the broadcast address, while the other packet contains just plain IP addresses. You can configure Wireshark to just display the machine addresses by clicking on the View menu. Going to the Name Resolution submenu and toggling the Enable for MAC Layer menu entry. As you can see, the address names switch to plain MAC addresses. Going on, the protocol column contains the higher level protocol carried by the packet like ARP, DNS, ICMP, TCP, or HTTP. The length column contains the size of the packet. Finally, the info column contains some protocol-specific information, like a human-readable ARP request, information on the ping packets captured, details on a DNS query, and so on. Wireshark is also a protocol analyzer. A great way to manage the packets during an analysis is display filtering. This feature lets you display just some of the captured packets by setting filters on protocols, field values, and more. You can set a filter by clicking on the Filter button and selecting one of the default filters. Let's choose No ARP and click OK. As you can see, the ARP packets disappeared. In fact, if we scroll to the top of the packets list, the very first packet is number 3. And, if you remember, the first 2 packets captured were where ARP requested a response. To restore the previous unfiltered display, we have to click on the Clear button in the Filters toolbar and get our ARP packets back in our packets list view. You can try other filters from the Display Filter window. For example, we can select UDP only and click Apply to see how the packet list gets updated. Or select and apply the TCP only filter. Please notice how any action in the display filter is reflected in the filter input text box. Let us try a more complex filter, like no ARP and no DNS. Not only are the ARP and DNS packets no longer displayed in the packets list pane, but we also have a complex display filter expression in the filter input text box. The filter is made by 2 expressions, not ARP and not UDP port equals 53. Please note that you can use an exclamation mark in place of the not keyword. The 2 expressions are combined by an AND logical operator. You can also write your filters manually by typing them in the filter input text box. For example, if you write ICMP and press Enter, only ICMP packets will be displayed. If you write IP and press Enter, every packet using IP as protocol will be displayed. This includes DNS, HTTP, ICMP, TCP, and UDP packets, as these protocols use IP as network layer in their stack. ARP packets are filtered out. After clearing the filter expression and pressing Enter, ARP packets are displayed again. If you remember, ARP is a low-level protocol and does not use IP. Scrolling down our packets list, we find some HTTP packets. Wireshark can parse and understand some common application layer protocols like HTTP, and this is very useful when filtering traffic. We can write the name of the protocol, HTTP in our case, followed by a dot, and Wireshark displays all the fields of the protocol we can use to build our filter expressions. In this case, we want to only display HTTP GET requests, so we input http.request.method == get as filter and press enter. Now, Wireshark displays all of the GET requests performed during the browsing session, like opening the site, loading the scripts and style sheets, accessing the admin area, and so on. If we only want to display post requests, we have to just update our filter and click enter. As you can see, there is only a post request. This is the login request we performed earlier. Please refer to the Web Applications module and videos for more information about the HTTP protocol. Let us clear the filter to see how to use the other two panes of Wireshark's main window. This pane lets you see every packet's details, drilling down to get information about the application layer protocol in use, its specific header's values, the transport protocol in use, and, for example, the source and destination ports. Internet protocol information like the source and the destination address, data link addresses, and physical layer information. In the lower pane, you can see the raw hexadecimal representation of the packet. You will see more on how to use Wireshark to study protocols and analyze traffic captures in the following video. We can now restart the sniffer to configure some capture filters. So, we reopen Wireshark from the menu. We select the interface to use during the traffic capture and click on Capture Options. As we saw earlier, clicking on the Capture Filter button opens the Capture Filter window where you can select some default filters such as UDP only to capture only packets using UDP as transport protocol, TCP only to capture only TCP traffic, HTTP traffic, no broadcast and multicast to capture only unicast traffic, no ARP to filter out ARP requests and replies and others. During this second session, we want to capture only HTTP traffic by selecting the HTTP TCP port 80 and clicking OK. Please notice how the filter selection gets reflected in the Capture Options filter window as an expression in the filter input text box. This filter will be applied on the traffic scene by the capture interface we selected earlier. Click the Start button to run the capture. The capture pane is empty, so we will generate some traffic to see what happens. We start with the ping command, which uses only the ICMP protocol, by typing ping admin.site. As you can see, the capture pane remains empty because the capture filter is discarding any non-HTTP traffic. Let us try with another protocol. First, we stop the ping command by hitting Ctrl+C. Then we perform an NS lookup for other.site, and then admin.site. The capture pane remains empty. On the other hand, switching to the browser and performing a page refresh generates HTTP traffic, which is captured by Wireshark. To verify that, we can close the browser, restart the capture in Wireshark by clicking on the Restart button on the toolbar, reopen the browser, and connect to admin.site. Note how every HTTP traffic gets recorded. For example, if we log in by entering the username, the password, and clicking Sign In. The packet's capture list is updated as soon as some HTTP traffic is made. It's time to save this capture to a file. Please note that you cannot save a capture while the sniffer is active. We have to stop the capture and then save the file. We name this file HTTP only and click Save. Capture filtering has a huge impact on the size of a capture, as Wireshark will discard any non-matching traffic. We can verify that by switching to the terminal and performing a list command and passing sh as parameter. Please note how the first unfiltered capture is 264 kilobytes, while the second is just 20 kilobytes. Try to use Wireshark at home, or in Hera Lab as much as you can. It is a great tool to understand and troubleshoot computer networks and protocols. And this concludes this security video lesson on Wireshark. Thanks very much for joining us.